Here's how you can handle banked curve problems. So this car, it's alongside this inclined road here and it's driving along this curve. We want to calculate centripetal force. So the way you can do this is by taking this car here and drawing it as a free body diagram. And by the way, this is the mass of the car. It's 1,000 kilograms. And notice here that we have a weight force that points straight down, but we have a normal force that points at an angle. Since the normal force points at an angle, we can draw a horizontal and a vertical component of our normal force. Now, the first thing I want you to notice is the relationship between our angle theta and the angle of our right triangle that we form with our vectors here. This angle is going to be 90 minus this angle. So we have 90 minus 20, which is going to be 70. What I'm going to do is give you an equation for the normal force. Now, the normal force is going to be mass times gravitational acceleration divided by the sine of phi. Now, this right here is phi, and it represents the 70-degree angle. I did not want to make this theta because theta would represent the 20-degree angle, and notice here that we're dealing with the 70-degree angle. I'm also going to simultaneously calculate the weight force, which is mass times gravitational acceleration. So plugging in all the variables, you should get 1,000 for your mass, and you should also get 70 for your angle phi. 9.8 meters per second squared is gravitational acceleration on Earth. So if you evaluate both the normal force and the weight force, you should get these two numbers right here. Now that we have this force here, we can calculate these components using trigonometry. Notice that this horizontal component is adjacent to this angle. What that means is we can use the cosine for adjacent angles. So if we take our normal force and we multiply it by the cosine of phi, we can calculate our normal force in the x direction. So if I plug in my values for phi and for the normal force, you should get 10,429 times the cosine of 70. Should give you approximately 3,567 newtons. So that's the horizontal component of the normal force, and this is also the centripetal force and the answer to this problem. But let's say I asked you to calculate the remaining forces. Notice that you have a right triangle, and the only force missing is this vertical component. So you could use the Pythagorean theorem, or you could just recognize that this vector is equal and opposite to this vector, which means that the normal force in the y direction is going to be 9,800 newtons. And those are all the forces solved in this banked curve problem.